Okay. Hi. So I hope you're doing well. I hope you've been studying for your linear algebra exam. We are going to talk a little bit about the Rank-Nullity Theorem. This should hopefully be a pretty short video because the Rank-Nullity Theorem doesn't have that much substance to it. So once you understand what's going on with it, it comes together pretty quickly. So the question that was asked on the test is, if A is a 2 by 5 matrix, is it possible that the nullity of A is equal to 2? Explain your answer. So first thing I did, just kind of to understand kind of what I'm looking at, I just drew out like a sample matrix. So I'm just going to say like X, Y, 1, 2, 3, 4, 5, 6, 7, 8. Okay. That's what a 2 by 5 matrix looks like, right? And just looking at this, I can see that it is going to be impossible for us to have more than 2 pivots. And like it doesn't matter what these variables are. So I can just say like 1, 0, X, Y, Z, A, B, C. That doesn't matter. But the important thing to understand is that there is a maximum of 2 pivots, okay? These are our pivot columns. So when we talk about rank and nullity, we haven't even gone into any of that yet, but we need to understand what rank and what nullity are. So the rank of A, so matrix A, is the same thing as the dimension of the column space of A. Okay? So first things first, we need to understand column space. I can make a video about that later. It's a little bit of a complicated topic to cover in just this one. So if you need help with that, I can make another video. But what you need to just know here is that this deals with specifically basic variables. Okay? So basic variables is honestly another word for pivots. If you have basic variables, that means you have pivots in those columns, okay? So in our sample matrix up here, there are 2 basic variables because we have 2 pivots. So that means that our column space will have only 2 different vectors in it, okay? So our dimension is the number of vectors required for our column space, or just like any vector space, but specifically here our column space. So what this is asking, the dimension of the column space of A is asking how many pivots are possible. Okay. Or I guess more of how many pivots are there? Okay. In this example, let's think about it, right? So this matrix has up to 2. So that means that the dimension is either equal to 2, 1, or 0, right? Because it's possible that there are 0 pivots in this entire thing, right? But it's also possible that there's only 1 or there's 2. But we know that there cannot be any more than 2 because we have a limiting factor on the number of pivots. The nullity of A is very similar, but kind of the opposite at the same time. So the dimension of the null space of A is what we're looking at here. And I can also go into null space in a separate video if you would like. But basically, the null space of A, this deals with our free variables, okay? It's a very important thing to remember. The column space deals with the basic variables and the number of pivots. The null space deals with the number of free variables and the lack of pivots, okay? So in a matrix 2 by 5, I'm going to say, well, let's go back to our perfect one, the ABC, XYZ, the 2 by 5. you can see that 3 of these, at the minimum, will not have pivots, okay? It is also possible that we will have a matrix that's like 1, 0, A, B, C, D, X, Y, Z, W. Okay, this one has 4. It's also possible that there are 0 pivots and you can have up to 5 free variables. Okay? That's an important thing to keep in mind. Actually, now looking back at this, there should always be 1 pivot. So disregard this 0 here. That was right over here. I apologize. I realized that I messed up there. But this still applies the same. There are either going to be 3 or 4 non-pivot columns, okay? And the number of non-pivot columns is our dimension. So our dimension is equal to 3 or 4, one of those two. And then basically, you remember how we always say it's an m by n matrix? Just whenever we're making a matrix, it's an m by n matrix, okay? In this situation, 2 is our m, right? And then n is 5. So it's a 2 by 5 matrix. Well, remember this as our n. That's important. Because when we actually talk about the Rank-Nullity Theorem, which just kind of pulls together everything that we've just talked about, all it says is that the rank of A plus the nullity of A is equal to n. Okay? So this one is the dimension of the column space of A. This is the dimension of the null space of A is equal to, in this situation, it's going to be 5. It's always your number of columns. So, if you look at this, it makes a lot of sense, actually. So let's say we scroll up to, let's look at this one, okay? So this one, we can see that it has 2 pivots, 3 non-pivots, okay? So this relates to our rank, this relates to our nullity, okay? Let's add those together. 2 plus 3 is equal to 5. Look at that. This is our rank, this is our nullity, this is our n, our number of columns. And it works with the other one too. So if you see this one down here, there's 1 pivot. Okay, so our rank, I'm just gonna call it R for here, for now. R is 1 plus our number of free variables here, which is going to be 4. 1 plus 4 is equal to 5. Look at that. This is our nullity. This is our rank. It works just like that. Hopefully that clears things up a little bit. I hope it worked out for you. If it doesn't, ask me some more questions and I can try to answer it best through text. If I need to, I will totally make another video. Just let me know. I will do my best. All right. Hopefully this helped. Thank you. Bye-bye. I gotta find the ending.